Well, we can start, and more people join. And just feel free to, keep chatting if you want. Today, again, we'll try and get you guys driving as soon as possible. Okay, I think it's really fun, but let's wait a bit more. And
Hello, Professor.
hey, who is this? Yushin?
Yeah, it's me. And today I join with my cell phone.
Oh, I see. Okay, so you can't code.
Yeah, because my laptop have some problem.
That's okay. But you can participate in the lecture, right?
Yeah, I can use the cell phone.
Yeah. Anyway, I'm pretty sure whatever we do is going to be recorded on YouTube, so you can follow up later too. And if we do any coding exercises, when you get to a laptop, eventually,
Okay.
You should try them out. Yeah.
Okay, thank you.
Sure. No worries about that. Thanks for joining, despite having only a cell phone.
Yeah, I can
But,
use it.
it's really kind of cool, isn't it? Because I really think maybe I should talk to Ram or someone at Foothill about this. I think the lecture format is working well, and you guys are working together well enough that we can pretty much, if possible, just open up this class right to the whole world, and pretty much make it free for computer science education anywhere, right? Anyone, anywhere in the world, as long as they have an internet connection. You'll be surprised. There are many countries in which people have super duper sophisticatedly, super duper good internet connections, but they don't have other, basic infrastructure. The roads may be broken, the politics may be horrible, right? There's a whole lot of corruption, but if the internet goes down, there'll be a revolution, right? So like that, there's lots of countries like that. I know, right? And people are very intelligent. They have free access to information. It's just because of some corruption here and there, things are out of balance and things are not progressing overall. But individual people, they're all exactly as bright. So if they have an internet connection and a pretty decent phone, which really is getting to be so cheap these days, right? So anybody could sit on a pavement on a corner and participate in our lectures, right? Well, I don't know. I think Zoom for Foothill has a bigger limit, right? It's not like 50. We can actually have up to 300 people in class right now and be driving. And you could all be interacting. It'll be rich interaction. We'll be coding some really, juicy problems too. And then there'll be greater scope for, at the end of class, to break out into bunches of people who are interested in the same things. But maybe these groups aren't even composed of people in the same neighborhood, same country, right? But you'll all be virtual clouds of people working on similar interesting things. I think it'll be cool. Maybe I'll talk to because as far as I'm concerned, I was thinking it's not a great deal of effort for me, whether it's 30 people or 300 people or 3,000 people, right? All I have to do is just show up here and answer interesting questions. And the more people there are, the more interesting questions are going to be, right? So we can eventually, hopefully, have so many interesting questions that we can start ranking them, right? By degree of usefulness, a priority of votes, and then we can go through those questions and we can use these lecture hours for those things, right? And yeah, that'd be fun, wouldn't you think? Right? You guys are having more fun, I think, because I watch the videos. You guys are really having fun coding, and it is not at the level that I would expect, like 5 classes into quarter, right? It's more, 5 classes into CS2A. Really, you're looking for people to do more beginner stuff, right? You're trying to get familiar with things and so on, but you guys are actually coding up some interesting stuff, right? And trying things out, and actually making the computer do things so that the interaction will be rich between you and the computer, right? Those are things that you would expect to happen towards the end of CS2A. Yeah, so which it has, it's a knife with two edges, I think, because it's fun, but I am also concerned that maybe not all of you are there, right? So what happens if like 90% of you are comfortable with this code, right, and doing cool stuff on screen, but there's a 10% of you who are not able to come in. But I was actually very pleased to see the video, because I think Alex or someone kept asking everybody, right, are you guys okay? Are you guys together with us, right? And I think I heard that at least 2 or 3 times in the video, which was really good, because that's the way to all stay together. And so when I'm not around, just be on the watch out for people who may drop off, right? Because I know it gets really, really hard when you're in the heat of the moment, right? Because when you're in the heat of the moment and you're really, really working on something, with all of your cylinders firing on it, it's very hard to also keep an eye out for people who are falling off the train. Yes? Because you really want, because the lecture is going to end in 2 hours, or the Zoom recording is going to end, and we want to get something done before then, right? So better to finish it off than to make sure that we all go together and stop someplace and then pick up next class, which I think would be better, but it's really hard. But you got to, if you can consciously watch out, for those kinds of situations when I'm not around, and basically make sure you yank people. It doesn't matter if you don't finish something before the end of class. Right, so I think that is also a pressure that many students feel, that, oh no, maybe the professor will be disappointed if we don't finish it, right? I can tell you right now that I can never be disappointed, because you're already past week 5, lecture 5 or whatever this lecture is, right? So I don't expect you to be working on that kind of stuff right now. So you're already past my expectation. So you can't disappoint me if you don't finish something. But yeah, I will be disappointed, not for you, but I'll be disappointed for the other guys, who drop off the train. So I think it's better for us to keep an eye out for these people now, before our class grows to like 3,000 people, right? 3,000 or 300,000 people. Then we need to have individual people, like class monitors, who can handle up to 300 people or 400 people, right? And we'll have to develop some kind of system, but or filter down the questions or something like that. How did once I did a MOOC at UPenn, modern poetry or something like that. Wow, that class was huge. I think it was like 150,000 people. 150, maybe it's 150,000 people all over the world. I don't know. Maybe it's 15,000. Maybe I'm far off by an order of magnitude. And Al Philrice, I think that was the name of the professor. And he only had like 5 students with him. But it was a MOOC. It wasn't a face-to-face class like this. It was a MOOC. I don't know. Yeah, maybe there's a risk that if we take 3,000 students into class or 300 students, it look more like a MOOC. But I don't think there's any great difference between a MOOC way of delivering instruction and face-to-face, if you're not going to give away answers, right? If you're just going to nudge people in the right direction and have them think out the answers themselves, it doesn't matter if you're telling the secrets of the trade to 30 people or 3,000 people, right? Because they're all going to try it. You want all of them to try it. And the bigger the sample, the more, the better the likelihood that more of them will survive, right? And then we'll create a healthy funnel, and the funnel will start widening slowly, right? Because the more people that are enthusiastic and interested in this, the more they'll want to teach other people too. Because, a joy is not fully enjoyed unless other people around you are also enjoying it. Right. So after you're already content and sated and said, okay, I'm happy as can be, right? I don't want anything more. The only thing left for you is to basically spread the joy so that other people can also enjoy it. And I think that's how the funnel kind of starts widening. And so you guys might be a fantastic test bed, right? Because I'm actually watching you guys, but not out of, this is what I want to do, so let me try it out on these guys, but I'm just actually seeing this thing come out of amorphous, It's just coming together very nicely. And I'm watching this video and I'm thinking, does it matter if it's like only 30 students, or or it doesn't matter if there's like 300 students and all, anyway, I got to get my, telescope goggles on before I can see all of your faces very clearly, right, on my small screen, right? But still, it doesn't really matter as long as you're all present in spirit and you're all talking to each other, and then receptive to ideas, right? Receptive to ideas, so that you can actually pick up on these things and start working on them, and nudge other people and get them all interested. So it's all part of not just CS2A, but also your life skills as an entrepreneur, as someone who's going to start a company or do something interesting. If you have an interesting idea, right, there's only so much you can do. You can fire on 15 out of 10 cylinders, right? So you can, but still there's only so much you can do. But if your idea is really strong, you need more manpower, you need more energy, right? Than one person, how many ever carbs you can consume can bring to the table. So you're going to have to be infectious with your zeal, with your passion, so that you infect as many other interesting minds around you to be not answerable to you, right? You don't want anyone to be answerable to you. That's a real pain, right? Nobody wants to be a manager. I can tell you that, right? So the best manager is a person who can actually get other people interested in the same thing, right? So you don't have to manage them anymore. They're all self-managing entities because they're all interested in the same thing, right? Because managing people is a pain in the ass. Because, then you either want them to be, beholden to you like a slave, which again is a pain because you got to watch over them, right? Regardless of the implications and all that, right? Or you got to, not expect the best from them. You got to say, well, this is what needs to get done. I'll give you this much in return, right? And so you're not getting it, right? So what you have, and so that's what you develop, right? In these groups, when you work in CS2A and projects, and you have a really interesting idea, right? It doesn't matter if someone has worked on this idea before. None of this matters. If you talk to people around you and make it interesting to them, right? Maybe it's an old idea, but you just recast it in a different way, or even put it, phrase it in a way in which it looks like a new idea. That doesn't matter, right? It is not plagiarizing. It is not stealing. As long as you're able to identify the ability in you that can take something that is boring and make it interesting for other people to look at. That's, it's the same, whether you're a writer, whether you're, an artist, or sculptor, or a programmer, it's all the same, right? It's taking something that's probably uninteresting most people, right? But there is something interesting in there. It's not like it's a hunk of metal, right? So I'm going to chip it out of there somehow, right? But after I've seen it, now other people should see it too, right? So then these start, and I think, but how do you make that interesting to other people, so that other people will also be interested in the same thing, and you can all be working on the same thing, right? So everybody has that in them, and I've seen lots of kids, right? When I see these, not so much grown people, but I've seen this in a lot of kids, all right? When they're interested in something. And if you carefully watch, right? If you carefully watch your little nieces and nephews, brothers and sisters, if you guys are young enough, so you can actually observe this, right? If they're interested in something, they are not going to rest until they get other people around them interested in the same thing, right? And it doesn't matter if they're going to lie or try and make it more interesting than it actually is, but they'll try and somehow get your attention into this, right? And maybe it doesn't on adults, it maybe doesn't work as much, but it works on fellow kids, right? If they ask their neighborhood kids, or their extended family, they're going to try and make this idea as interesting to them as possible, right? So that everybody is now focused on the same thing, and they're all trying to solve the same problem. Now, so I think that is, but somehow that needs to be polished. Once you identify that, you need to polish that, right? Because if you identify the skill in you that is able to sell an idea, however boring it is, it may have some interesting components to it, right? To be able to tease out those interesting components and present them to others, right? Because you're not trying to make anything, you're not trying to sugarcoat or tell any lies, right? But everything has interesting stuff in it, but you just have to be clever enough to tease it out and then show other people, no, it's not actually boring like you thought. There's actually interesting stuff in it, right? And this is the interesting stuff. And they'll say, yes, it is interesting. It's actually worthy of more thought. Let's all get together and think more about it. So that, and I think, so if we identify that early enough and say that's the skill you need to sharpen, if you want to be a successful entrepreneur, Meaning that, well, it doesn't have to be an entrepreneur too, right? Any field, once you have an idea, even if you want other people to work on your math proof, right? If you have a conjecture in your head and say, well, this has to be true, right? But I just can't prove it. But I can get up to here, but I cannot prove it. But it has to be true, right? But I know that if I talk to this person who has actually been in this area for several decades, right? They'll probably figure out the answer. They'll at least tell me if it's false, right? Or give me a counter example or something like that, right? But how do you get them interested enough? Because it's not like, go and ask them if I toss this coin. No, it may be something that's involved, and they have to look through a lot of stuff before they come to the question that you is actually plaguing you. But how do you get them interested enough to look through all of that to answer your question? And so this skill is a very useful skill. And I think the people that are most successful in getting other people to also do stuff that they're interested in, so that they all together harness their collective manpower to do something greater than what one person could achieve. Right? Because you cannot force someone. People today look at the pyramids in Egypt, right? Look at these great temples in India and the Great Wall of China, and they say, this were all of this built by slaves. Drivers with whips and saying you got to do this. No, but many of these intricate structures, these beautiful things that you see, right? If you go inside the pyramid and look at all the geometric structures, right? And they couldn't have been built by slaves for no reason, right? Someone had said, I have to do this because it looks beautiful, right? I have to do this because it gives me a sense of fulfillment, or whatever it is, right? If there's a stone here, I need to take it home so that it'll be a memory of this thing that I built in the pyramid. That's how the millions and tons of stone disappeared from the desert all of a sudden. I don't know, there may be some rational explanations for all these things, right? So I think you cannot just force people to do stuff that you want and get the best product. The best products always come out of groups of people that all are wedded to the same goal, right? Not working for any other human being, but working towards an ideal that's beyond humans altogether, right? Maybe it's a product that everybody's working together, So by working in groups in CS2A, and I think that's why computer science is so good, especially this class, because it lets you work on a lot of these ideas that you're coming up with, like this game of NIM that you guys are coding, right? And as you're coding, I can see there's like a million different variations of this game you could do. Right? You can sugarcoat it in different ways. Maybe eventually you'll learn JavaScript and come up with a version of this game that has avatar characters in it or something like that, right? And you publish it on the web. But it all boils down to this thing, right? That you built in class. And so you're coming up with all these interesting ideas. And the beauty is that, unlike in some of the other physical sciences, where you can also have interesting problems, right? You're going to have interesting problems, physics, aircraft building, ship building, whatever it is. Every one of those requires an investment of, significant time, energy, and money, right? Even if it's a simple experiment in science, I don't know, maybe you got to buy a couple of, test tubes or whatever. Maybe it is a meter of some kind that, measures, right? It's going to cost you a couple of bucks at the hardware store. So, but computer science, you have an idea and you can go from your mind to actually seeing it happen for $0. Well, not really $0, right? A few cents really, because what you're talking about is just the bandwidth you're paying for and the electricity of the computer, which also you get for free because, you pay taxes, you go to a library, you get internet and a computer, right? And compilers are free online, right? Many times. And if it's JavaScript, you don't even need a compiler, right? You can just basically develop your entire program inside of Chrome or Edge or something like that, right? So, or even VS Code, right? So your entire web app can be created right there and uploaded, bam, to an Amazon or Google bucket. And right now, right, you go into a library and you've basically created and deployed an internationally global, multinationally, infinitely scalable app in 10 minutes. Right, deployed it, made some changes, looked at the stats, and then come out, right? And you just go to a library and come out in half an hour, but that's what you've done in the half hour, right? And basically have your fingers everywhere, right? So, and it's interesting. You get lots and lots of data, information, and you'll find it's very fulfilling. So I think so. I think this whole thing is going well. So today, by the way. If you have any questions, obviously, I'm happy to answer any questions. But otherwise, today, I think, is it week 4 or week 5? I keep forgetting that. Week 3, Alex? Oh, 4. Thank you. So 4, I think we're supposed to talk about arrays, right? And it's kind of cool that we talk about arrays because arrays comes after branching and looping. The next thing to know is arrays. After that, we'll talk about functions. Next week, we'll talk about functions, right? And then it's a midterm, and after you come back from the midterm, then we'll talk about classes and objects. That's real C++, right? Until then, it is simply essentially C program, right? So most of what we're learning now is just C, except for some of the constructs we're using. So it's working out quite nicely. So you guys should ask me any questions if you have about arrays, or when you take the screen over, and maybe whenever 10 minutes or 20 minutes or whenever you take the screen over, try and pick a problem. I'll give you a couple of problems too that involves arrays, right? Maybe if you don't have anything at all, you can say I'm going to let's assume that I'm given I'm going to create an array of 1,000 random integers. Everybody knows how to create a random integer, right? Okay, so I'm going to create an array of 1,000 random integers between I don't know, pick some numbers between, let's say 10 and 50,000, right? Pick a random number between 10 and 50,000. So that itself is a little micro challenge for you, right? How do you pick a number between 10 and 50,000, right? Using rand, obviously, right? You have to use modulo and plus and so on and so forth, but you can figure it out. So and you're going to generate, I don't know, 1,000,000 numbers like that, or 1,000 numbers. So you can play with array size. You can see how big your array can be, right? So you're going to create an array of that many integers, right? And each one of them is going to be a random number. And then you can start your playing with the array. You can say, now I'm going to task myself with finding the average of all of those numbers, right? I'm going to task myself with finding the maximum or minimum of all those numbers. So those are easy problems. Now, finding the average of 1,000,000 integers is not actually as trivial as I think it may be if you're just going to stick to integer space, I think. Yeah, I think if I think we can come up with a problem. I'll leave it to you, right? If you guys come up with this problem, right? If you come up with this problem, I think it'll be really cool. So the problem I'm thinking of is that I want to find the average of an array of numbers. Yes? Okay. Yes. All right. Now, in order to find the average, I have to sum up all the numbers and divide by the number of numbers. What happens if the sum of all the numbers is bigger than the biggest integer? Yeah, that's possible, isn't it? Yeah. So we got to come up with some clever scheme so that no matter how big the array, you'll still be able to find the average. Right. In fact, I haven't thought of one, but I'm pretty sure there must be one. Right. So I leave it to you, but you don't have to do it. I mean, you can when you start coding, you can code the simple one, right? So assume that the sum of all the numbers is going to be smaller than the biggest integer, right? So you add it all up and divide by the total. So the max min. When you've done that, you can do some of the more challenging things, which I think is identify all pairs of numbers in the array that sum to 55, or some random target you pick, right? So pick some random target and say, can I now enumerate every pair of numbers in this array? Now you see that you're starting to tread into the areas of computer scientists, not programmers, right? Now, why do I say computer scientists? Because now you see there's many ways to do it. One way, obviously, is to consider every single pair, right? If you have n items, how many pairs are there? N choose 2, yes? How many ways of picking 2 items out of n items? Yeah, n choose 2, n times n minus 1 over 2 factorial, yes? Yes or no? Right? I don't know, some of you are, I think they teach this in discrete math, right? It's a discrete math, but is discrete math a prereq for CS2A? No? So what is it? It is a prereq for one of our courses. Which one is it? Maybe for CS2C. I don't know. All right. Anyway, so it is related to n times n minus 1 over 2. That's n squared minus n over 2. So as n becomes bigger and bigger, the number of pairs you have gets square, right? It grows like the square instead of growing by 1 like n. which is really bad, actually, if you think about it. However, it's not, if you know, the thing is, when people sitting in linear land look at, quadratic algorithms, this is what they think is, so linear is increasing by 1, 2, 1, 1, 1, 1, 1. So increasing linearly, that's a straight line, right? One step, right? For each x, you raise up 1 step, that's linear. 1 or 2, so constant amount, constant. So that's linear. However, quadratic is, goes like a parabola, right? Because, initially it grows slowly, and then it goes by a square, it goes faster and faster, right? So sitting in linear land, people in computer science, we say, quadratic algorithms are really, really bad, right? Because we can do everything in linear time, right? We can do, our time only grows proportional to n, does not go proportional to n squared, right? The quadratic folks are bad. Right. However, there's a whole family, far more people than you can even imagine exist in linear land, exist in, post quadratic land, cubic and exponential land, unsolvable land. There's so many other people out there, right? And you ask them, they're going to say, even if I can spend like a couple of seconds in, quadratic land, that'd be great for me. It's so great compared to where I am right now. So, the other side, so many people in, with cubic algorithms right there, right today. Even big companies running cubic algorithms, even some exponential algorithms within bounds. All kinds of crazy stuff is happening. People throwing a lot of resources, wasting a lot of money, wasting a lot of carbon, right? Running energy, because they may say, I have a lot of money, I'm going to just throw a lot of service at it, right? So my map reduce it to the whole of Antarctica, right? So things like that. And but is it really necessary? Right. And the thing is, that's the thing that computer scientists are looking for all the time. So, just because we have a lot of power doesn't mean we have to use a lot of power. So what we say is, there's a lot of companies out there that don't know that, because they don't have true computer scientists. They have programmers, right? Programmers and developers who say, I can get it done by the computer for you. Not saying that I can get it done in the most efficient way, which is a computer scientist way of saying things, right? But a programmer would say, get it done. But a random Joe out there doesn't even know if it can get done by a computer. Right? Many people with lots of money, maybe not anymore, right? Lots of people with lots of money and resources, and they've just heard about computers, and I say, well, let's get a computer to do it. It's going to cost $1 million and do it in a really, really inefficient way, right? But they'll still be happy, and they'll be happy to say, I got a computer to do it. But that's because some random person just coded it at home. And a computer scientist would say, no, you actually, you know what? You just spent a fortune doing something that you could do, in your sleep, right? So this is what we've studied this for a couple of centuries, and this is the way you do it. And it's so simple, you don't have to do anything at all, right? So they can actually show it to you, and that's what computer science teaches. And I don't know where I was going with that. Yeah, arrays, right? So you can, and you can say this is a quadratic problem, right? But is there a better way to do it? Is there a better way to solve that problem than by examining every pair of numbers? Yeah, so that is not a subject of CS2A, all right? However, it is a subject for your pastime, right? So instead of watching a Netflix film or on Prime, you can say, well, the next hour, instead of that, I'm going to think of this, right? And you'll actually find it's actually worthwhile, right? You say, you know what? I know for sure I can do it if I pick every pair. But is there a way I can do it without having to pick every pair? Right? Maybe you won't do it in 1 day or 2 days, right? But eventually you'll figure out. So, and it'll be a fun exercise, right? And and you'll start figuring it out. But today in class, you don't have to do that, right? Even if you already know the solution, don't say it, right? Don't, because you may be spoiling the experience for other people. So that's maybe you don't even get to that problem today. That's fine, right? But if you do get to the problem, code it, and if you know the solution, don't say this is how you do it subquadratically, right? So because everybody should do it quadratically first, at least in their mind. But it's we say it's coding in the mind and coding on screen in front of people, pretty much the same, right? So everybody should code it quadratically first, and then try and quadratically meaning examining every pair. You know how to do every pair, right? Start at 1. But that itself is an exercise. Double loops. Maybe you'll do that today, right? So yeah. Actually, before you even get to this, you can after doing the sums with things with arrays, or even before that, you can try this. Okay, someone remember? Maybe bring it up and right is to given given an array of numbers, you just have to print every pair only once, not twice. right? Every pair of numbers in the array only once. So if I'm given, if I've given an array of 1, 2, 3, I think it'll print 1, 2, 1, 3, 2, 3. Yeah, is that it? Those are the only pairs. Yeah, because 3, 1 is the same as 1, 3. So you can say that. So now you probably already know the solution, right? So how to do it? But you basically you can implement that in 2 loops. 2 loops, 1 loop contained inside of another loop. Right? This is a standard idiom, right? So anytime you want to do pair generation, that's what springs to your mind. You don't even think about that, but So you say, oh, all right, I'm going to do pair generation there, right? But you don't know how you're going to do it, but it can do it. When you have to do it, this is what you'll do. So so that's one of the things you can do today, right? Today, first thing you do is get an array and say, this array, I'm going to print every single pair. So maybe it's an array of strings and it has all the names of these students, right? So let's say we started, so maybe I'm off screen, right? So you can say it's Yushin and Alexandria and Maddie. And so you put all the names as strings in the array, and then you're going to use the algorithm to generate all possible pairs. Maybe they're study groups, right? Before the final, I'm going to run this algorithm and say, these are all the pairs of students I get from CS2A, right? And I'm going to pick some random pairs and assign them problems. Yeah, so that's possible. So maybe you're going to do that. You can try that today. Yeah, and then after that, do the max, min, and statistics. Max, min, and so on. Yeah. Oh, you can call me. Okay, I'm just going to be around, right? I'm just going to be around. You can call me if you're stuck or if you have any questions about arrays, concept questions, no problem. Right? Yank me back in, and I'm happy to talk. So yeah, that one, and then max, min, and average. If you want to challenge yourself, try and think of a way, or maybe after class, right? Think about it in your own time of a way in which you can find the average, even if the sum of all numbers is going to be bigger than the biggest that data type can hold, right? Well, let's stick with integers for now, right? All right. What else? Max, min. Yeah, and finally get to the place where you can find all pairs of numbers that sum to a particular target. And when you do that, after you do that, then try and do that again with bigger arrays, right? And then you'll see, right? You'll see the bite of the quadratic there, right? Because you'll see, well, it's working fine for 10 elements, 20 elements, 30 elements, right? The moment I get past like 1,000 elements, I can actually feel the slowness, right? So and then 10,000, yeah, you say 100,000, no way. Yeah, but you increase the size of the array, and you'll have first-hand feel for it, right? You don't have to read a book and tell you that tells you this is what happens, right? Why do you need to read a book? Think about it. What I just told you, right? Hearing me tell it to you took about, I don't know, 10 minutes, right? If you read a book and trying to read it and understand it, another 10 minutes, right? But if you actually coded it right now and found out, I don't know, 12 minutes, right, max, right? So these days, books, instructors, they're all days of the past, right? You don't need any of that anymore, right? You just need one person in the group, basically just nudges you in the right direction from time to time, right? Just make sure you don't stray and get lost in the wildies, right? And then most people are intelligent enough to find their own way, right? Because everybody's progressing towards the same goal. So I think we can keep it like that. So unless you have any questions, what time is it now? Yeah, it's 8:33. Well, I think 20 minutes into class. I'm happy to answer questions. I'm happy to stick around as long as you guys want. I'm happy to code with you guys if you want. Yeah. And I'm happy to talk you guys through the first bunch of code if you like. I'm happy to drive and then hand over the driving to someone else. Anything you want is okay, right? So I don't care, right? I want to do whatever is best for you. I just know the stuff and I want to know. I want to make sure that you also know it, right? So so whatever works for you works for me. Because I can teach it to you in any different ways. Right? You say you teach it to me in this way, I can teach it to you in that way, right? And I used to teach in the traditional way too, right? With a whiteboard and notes and slides, and I've tried all kinds of shit, right? And I think this is what works best, right? Some students complain inevitably, right? I'm pretty sure most students used or felt like complaining before, right? But they were before the days when I used to teach more traditionally, right? Like other lecturers, right? Not here, but generally, right? More I shouldn't say traditionally, right? More like everybody else. I'm pretty sure lots of students also wanted to complain then too, right? Especially strictness with grading. Well, actually, I was quite lenient there too. But I don't know. Maybe they were complaining. They would have felt like complaining that they didn't know anything because they were watching YouTube and I didn't pick up on it, right, in the back of the class, and stuff like that. So there will be, but the thing is, maybe they didn't come up and complain in person, right? Like now people can feel free to say whatever they want, right? Because I'm also open and saying I don't care, because I'm just here to serve you. You just have to tell me, because that gives me fun. It gives me a great deal of fun to just sit around and tell you guys what I know, so that you guys could also do the same things as me, right? So I don't care. But I think so that actually frees it up, right? You can say whatever you want. I'm happy. I'm not going to hold anyone. I'm not going to penalize you just for saying bad things about me, right? And I think I make that clear now in my classes. But I don't think it is clear from an instructor who's teaching in the usual way, right? In the usual way, there's always fear of teachers, right? So as fear of speaking out, there's fear of asking questions, the fear of making mistakes in front of other people, there's fear of coding on the whiteboard. There's fear of complaining about the teacher to their superiors or colleagues because of repercussions, right? So I don't think lots of people came forward in those days because of the face that the usual teacher puts up is quite is stern, and I don't want that image, right? Because if you're stern, you can only get people to be less than as good as you, right? You get them to a certain, you pull them up, right? And that's no fun at all. What's the point, right? There's hundreds of people like that, thousands of people like that, right? So what you want is people that are as good as you, so that all of you together can do the same thing, right? Even if it's not going to happen, you're going to try your best. Hey, keep on trying, because there's a lot of fun. Just in that. So I think I think we're going in that direction with this kind of teaching, and I like it. If you guys want me to do the other stuff, that's okay with me too. Because I got all the notes. I got prepared stuff from years, right? Or I can just come and talk on the whiteboard, or like the recordings show on YouTube from ancient channels, right? Ancient times on our channel. You can do that. Yeah, I like this format. If you guys ask me any questions, I'm happy to answer. Otherwise, I'm happy to just give the screen to you, turn myself into mute, and I'll step away. I'll be around, obviously, right? How do I get two? Oh, I get two. Oh wow! Look at that. I don't know if you can see this, right? I got. You see that round? Do you see that round? Well, anyway, I got a round mirror up on there, and the sunlight over there reflects off that mirror onto this wall. But I've got two of these round circles on this wall here. I don't know how the two of them came. I don't know if you can see it. Do you see the two? 1 and 2 up there? So I don't know how I get 2 instead of 1. All right. Anyway, I'm going to be around. So yeah, if you can ask me any questions, ask me. Okay. If you can call me, right? Anytime you want, you can call me. Call me. Come back and talk about something. I'm happy to talk, right? Or if you have any questions, if you're stuck with programs and none of you can, or maybe some of you have come up with an answer and you want me to come and tell you if there's a better way to do it. Actually, no. If it works, don't ask me for a better way, right? Stick with what works, get the whole thing done, and then after the whole thing works, we can look at together, like next class we can look at that program and say, hey, can we refactor this? Hey, actually, can I think of refactoring? Was last class refactoring code, was that useful to you guys? Yeah, great, thanks. All right. I don't know, it's 2 people nodding heads, but I don't know, most of you haven't even got your cameras on. Fernando, Josh, I don't know, Madison has permission, Jared and Hiram and Soe, right? I think I saw Soe before. You've seen us on a phone, right? You guys are, Hiram and Soe, I don't know, you guys are probably not even here. All right, Josh is connecting to audio. That's good. All right, Hiram, Fernando. All right, Jared. I saw Jared before, I think. Or maybe Jared? Oh, Jared, yeah. Wow. Yeah, Zoom, very bad design, I think, right? So people just keep switching places. like that, bam, bam. It's like, all of a sudden one person changes into another, especially if they have the same background, right? Which, Zoom lets you do. So yeah, actually that's really cool. All right, great. All right, so are you guys happy to just carry on coding on your own? I want all of you to participate, okay? All of you, not just 2 or 3 of you, all of you to participate, and keep an eye out for people that are, because it's easier when there's 30 people, right? When it's 300 people, it's harder, and then you may have to break into smaller groups, right? I don't know if this is 300, right? So, but I'm saying that eventually you have break into smaller groups, and so that one person can go around, right, and say, okay, all right, good, guys, if you have any questions and so on, right? So you can do all that later. With bigger classes, but right now you got to make sure that everybody's on the board. Okay, please keep checking, because I know there are people that are struggling with some of the earlier quests. Now, the first few quests are usually harder to break into, right? It's getting over that. You're getting used to the question system, getting used to cutting your first code. Many people writing their first C++ programs, right? And first 3 or 4 quests is hard, easy but hard, right? Easy but hard. From 4 or 5 onwards, you'll start thinking more about C++. More of the mechanics will become second nature to you. So you don't think about the mechanics, you start thinking about the logic, right? That's where we want to get to as soon as possible. But it doesn't matter if it takes 1 month or 2 months or 2 years or 10 years, doesn't matter. You actually have to get to that eventually. Don't force yourself to get there, right? You got to experience all the pains of getting there, so that you know, and regardless of where you get thrown back, you can always make it back here, right? So you got to experience that. You got to see all the different paths of getting here, so that no matter where I'm here, if for some reason, if there's a tornado and I got thrown back here to Oz, right? I know how to wind my way back here, right? But if you just got lucky somehow because of some password, or someone without having to learn this, you went here directly, right? Then you're always fearful. You're fearful of bad things that can happen, because if you ever get thrown back here, you're never going to get back here, because you never made it here in the first place. Yeah, I don't know. Does it make sense? All right. So that's how it is with programming too. I think it's good to experience all of this, right? All of this before getting to 2B. 2B, I've been doing more digging into why there's such abysmal performance. There are a lot of students in CS2B this year who just came in with no knowledge of mechanics, right? They just learned programming in their garage in the bad way, in the wrong way, and many people confuse being a handyman or I think, right, being able to throw some hardware together, right? Starting all the way from Arduino kits to sophisticated, NAS bridges and things like that, right? People do that at home for a hobby, right? Yeah, everybody with soldering irons and things like that, people do that. But and because you have to do a little bit of Arduino code and for that, and doing it in a bad way, a lot of people get confused, right? And the problem is there are a lot of people in the Bay Area, adults, who don't know better, and who look at shoddy jobs, shoddy workmanship, and say, you are cut out to be a computer scientist. That is the best computer program I've seen. You're a computer scientist, you're a programmer, and so on, right? And this gets ingrained into lots of kids, I think, right? So they come to 2B with an incorrect expectation, unless they've done CS2A and been filtered by our class to say, this is real programming, right? You got to learn. You got to learn how to write your own program. You got to learn to see what the errors are and debug them, right? Because when you do that step by step, you may be a full professional, right? You may be working at some multinational cutting code that is being released in the next 20 minutes to billions of users around the world, right? But you still know how you got there from the very first steps as a baby that you took, right? Because you went through every single step instead of taking any shortcuts. And I think that that is the thing that is missing. I think maybe there's a generation that has to happen, but there are a lot of students who just landed in 2B, right? Having miraculously cleared prerequisites without having cleared them, and then the rude awakening, right, is a very bad disappointment, and you really want to save yourself that, right? You really never ever want to find out in your life that you know less than you thought you did. I think, right, for critical matters, right? So it's for important things that really matter. If you just march ahead thinking you know something, but you actually didn't. And it's a critical path, right? It's a critical path. And if you're ever on a critical path that's something to do with your life, then you got to make sure that every step you take is a carefully calculated step, right? You know how to retrace it, go back if need be, right? Because in your life, you never want to be in a situation where you cannot go back and cannot go forward. So just like that, and programming, if you're learning it for life, learning it as a means of livelihood, right? If you want to make it your life, you want to make the right programs for your life, not just for money, for fulfillment, right? Very few people, right, do things for money, because, for money, think about it, for money, power, glory, you can only do it up to a certain limit, right? After you get after you get what you need, what are you going to do it for? Well, and you got a whole lot of time on your hands, right? And you know that you can do all of that in, all that is needed for my basic livelihood, I can do in like 10 minutes per day. What are you going to do for the rest of the day, right? So unless you really love what you do, you're not going to think about it. You're going to try different things, right? And so I think if you want to make programming your life, and which means you make a lot of money, obviously, but you don't care really, because you're going to do it for programming, not for, or building a product, building for something that will enrich the lives of others and thereby enrich your life too, right? Then I think it's very useful to basically step through all of these steps, unless you have a brilliant intuition, right? That knows that that actually empirically works out just like that, but you don't know how it works, right? There's many things like that, especially in math. Computer sciences, in math, there's so many brilliant intuitions, right? Mathematicians have all the time. They say this is true. How do you know it's true, right? They don't know. I don't know if it's true. Well, I know it's true, but I don't know how to show it's true, right? So they just know. They just know that's true. And then people spend years, decades, centuries, sometimes maybe even unproven, right? Look at Fermat's last theorem, right? For things like that. And people say, well, that person knew it was true, but they didn't know how it was true, but now I can prove that it's true, right? But how? So this complicated proof that requires a computer to show that it's true, but that person didn't have access to computers. How did they know it was true? All right. So and things like that. So sometimes you have a brilliant intuition and you just know it's true, then it's okay. But otherwise, it's actually, if you have spare time and you don't have a brilliant intuition, it's okay to just do the steps and say, hey, that's a lot of fun to do that step, because now that's better than before, right? Looks better. It's like, taking. There's actually a channel on Facebook that I happen to watch. This is a woman who makes some really creative, interesting, nice things, right? And she showed how to make a glass-like reflective sphere out of just clay from your garden, right? And she lumps it up and filters in and gets a silk, and then to polish it, it's an ancient Japanese technique, apparently, right? You just need any circular surface, right? So bottle cap, bottle top, right? Bottle mouth of a bottle, right? You just puts the blob on it and keeps rolling it. So the spherical thing there is basically going to shave off the edges. Eventually, it just polishes it and it rubs some wax and it's like a marble, shiny marble, but it's actually made of garden soil. So it's very interesting, right? And that's just keep doing that, and every time you roll it, it's actually very, I don't know. There's all these videos that my son used to watch, and then he gave up on it after a while. What's it called? Satisfying videos or something on Facebook, right? This is like 2 minutes, 3 minutes long, absolutely nothing to it, but people still watch them because it's basically made up lots and lots of video clips, each of which is very satisfying to watch. Like a flower, in high-speed flower blossom, right? A lathe cutting through a metal, right? Just a lathe cutting through metal. That's all, right? Like 2-second clip of lathe, right? There's like 100 clips like that. Lathe cutting through metal, flower blooming, tree falling down, right? Each one of those very carefully chosen, maybe algorithmically, to elicit the maximal endorphin response in viewers' brains, right? And it'll stitch together like a 2-minute video, and it's like viral, right? Everybody wants to watch it. It's like 1.5 million views, right? This is just ads alone has made up for all the time they spent in putting the thing together, right? So they've got that video, and it's very addictive, right? So you watch that, it's very satisfying. It secretes the right juices in your brain. But at the end of the time, you find there's lots of that around you. And you can spend your entire day watching it and nothing happens at the end of the day, right? So and like, I don't know where we're going with that, but like that, right? But there's some things that you can do that are also satisfying, like that. And this thing where she actually keeps rolling that ball on the mouth of the bottle is actually very satisfying, right? Because you can actually see it becoming a sphere right in front of your eyes. And then you don't stop, you keep on doing that because it's satisfying to keep it becoming, even though it's becoming a micro, approaching the sphere in micro steps, but you can actually see it, right? And that is micro satisfying, and you just keep doing that. So I think it must be like that bonsai art or Zen art. It's to slow down everything to just watch it at the micro level, and you'll see that there is actually satisfaction and fulfillment everywhere, right? As long as we just slow it down and just keep watching what happens, right? There's that joy in that change, right? Not change in you, but just change in the world. When you don't have, when there's no change in you, you're just sitting there watching, but things around you are changing. But those micro changes you can see, right? And you can see why those changes happen because of the mouth of the bottle, right? And things like that. And you start noticing a lot of these things that you never noticed before, right? Because when you think about it, right? When you're on a train, you can't see the tracks. Everything is like a blur out there. This is fast, right? When you slow down, you can see the detail. You can see the individual flowers on the side of the road, right? You learn to appreciate them. So I think there is a great deal of value in basically not just saying, I'm going to complete CS2A BC in 1 quarter, right? I'm just going to zip through the whole damn thing. I get I get A plus, and I've got this grade on I got a piece of paper. Well, what did you get out of it? Are you going to remember the A plus in 10 years time that you got in, at Foothill College 10 years ago? And after that, you've done so many things in your life, hopefully, right? So you're not going to remember that, right? However, instead of that 1 month where you just zip through it, right? You actually took your time, and you like the saying goes, you smell the flowers, right? So and you say, it's difficult, right? But I want to make sure that I know how to conquer that difficulty, right? Because anytime you come across a difficult thing in your path, if you don't know how to if you've got someone else's help and just yanking you over it, then that's going to be a source of fear for you in your life, because you don't know what happens if I get back in the same place and that person is not there to yank me over. What happens if I didn't find the free password? What happens if I didn't hack that system? What happens if that lottery ticket didn't, I didn't win? What happens? So that fear, because you didn't know how to cross that bridge. That happened by chance. So and it happens by chance because you're going fast. When you're going fast, you can just jump over things, right, without actually knowing. What happens if when you rewound, your jump is going to land you in the puddle, right? The calibration is off completely. So that's why it actually helps, I think, to take advantage of this time in your life when you don't have other responsibilities, right? When you start working, you have other responsibilities, you have family and all these things creep up on you, right, eventually. And so now is a time when you actually have the luxury of the expectation is on you to basically enrich your life. People are saying, I've now given you the chance to enrich your life. So now you can take the chance and say, now I'm going to basically do all these difficult things to see how many different ways I can fail. Because I won't get a chance to fail later. Now I get a chance to fail. Yes? Because if you fail now, you only get knowledge. But if you fail later, you lose money. Yeah? So I think that's the best way to do it. So try and don't jump ahead to stuff, and don't force other people at the tail of our class to jump to where you are, right? Don't yank them, right? However, go back to where they are and walk with them. Go back to where they are and walk with them, so that, even if you're gone, they can walk back on their own. Then if you're stuck, you'll see that they're there because they managed to walk back, right? So it'll all work out, right? And then you'll have more people working on your idea. Otherwise, you'll be the only one working on an idea, right? And it's no fun. So maybe it's fun, right? But if you are not the person that like that, right? If you want other people also to work on it or enjoy it, right? So then you'll have more people enjoying it if you are also trying to pull them with you. And it's also a great deal of fun to be with other people that are interested in the same thing. All right, I've been blabbering on and on. So I can take off now if you like, unless you guys have any questions or want me to talk about something in particular. I'll be around, right? So you can just call out to me and I'll be back. So it's like 8:15 now, right? 8:53. Is that okay with you guys? Can I just switch off the camera and go off screen, right? Yeah. All right. I'll leave. Actually, I'm going to mute my microphone also, so you won't hear me, but I can hear you, right? So if you want me, you can just call me. Okay. Hey, look at that hummingbird. Wow. Okay. All right. Great. Okay. So you can just call me. You just call me, right? And I'll hear you. And I'm pretty sure I'll be within earshot, right? I can hear you even from that far room over there. I can hear it, right? Okay. All right. See you. I'll talk to you guys soon. Bye.
I'll share my screen if no one else wants to.
Sure. Thanks.
Sounds good.
Well,
I can do like one later, like the average or something.
Your dog is so cute.
Thanks. Yeah. He loves meetings.
Oh,
what was it? We find all pairs of an array.
Yeah, I think like pairs of our names and then print them out.
So I'm picking an array. That's it. Is that right? I don't know.
I
uh,
think it
remember.
was,
I don't think so though.
right.
I think the brackets are after R. So like
Yeah.
space R brackets. And then Hiram, Maddie, do we need a number or no?
No,
Okay.
or maybe, I don't know. Yeah, I think you need a number in the brackets.
So
Sorry, I'm
so-
still thinking in Java, so
Yeah, me too. I work in Java all day. So
yeah, I'm taking Java 1C right now, so I'm
oh, that's confusing.
in that mindset, yeah. Wow, these are
that's
some
fine.
names.
Wait, no, that's not how it works.
You can do that if you
Different.
want.
So no one knows how to. What
Well,
goes
that's
after the
right.
equal sign?
I think you were close the first time.
Well, if you have the number, then you can't. You have to initialize it one by one, right?
Not according to what I'm reading on C++.com.
Oh, okay. I see it.
The curly braces are okay, right?
I guess you don't
Yep.
need the number in the brackets.
Oh, okay. Alright, and all pairs, right? So, or get the length of it.
We did this. What was it? Size? How do you get the size of the array?
Is it this?
Hold on.
Here, we can have the compiler tell us. All right, so that's not right.
Okay, time to Google.
Yeah. I thought it would be in here, but it's not. Hold on.
Okay, is it just array dot size instead of length?
I tried size as with parentheses and without, it didn't work. Unless there's something up here I need to include.
Oh, include
it?
array.
Oh,
Oh.
that?
Yeah, sometimes I don't know what Lewis did. I'm sure he didn't. We all been in that situation. We fight someone, and we go sometimes wheel to wheel, and it's close, and you have a lot of adrenaline going. Do you
Yeah.
think, comparing to football, if you have a microphone on a football player's mouth, that everything he says is something nice, that is a nice message when the guy tackles
I
him
think
and
this is about
maybe sometimes he fouls him or not.
class.
I don't think it's justified to give us this kind of questions and making up a story out of
Maybe it's
nothing.
some sort of prank.
We're full of adrenaline, and sometimes we say these
Yeah,
things,
right.
hit you in your face. Not gonna
It's gotta be Josh, right?
Is that Josh?
Yeah, that's Josh.
Josh?
But that's not his voice.
Well, yeah, I figured that much.
I think I want to ask the professor a question. Are you listening?
Professor. Is he in the call? Yeah, he is. Okay.
Yeah, I feel like we didn't use array last time.
Size
Size
of.
of.
Okay,
Will that give us the bytes or will that give us the actual size?
okay, without using size of.
Oh my
So I
god.
have to use that. All right, whatever. This looks easy. So I have to include this.
Okay, so they did like size of foo divided by size of foo 0.
Is
Yeah.
that really what we have to do to find the size of a array?
I don't know. I don't like that. But
what
it's
is
my size of.
Yeah. Okay, it's my size of.
Oh, you have to define my size. It's a method they made.
Oh,
You can copy paste it from their thing.
where was it? Oh, okay. Wait, no, I have to define it. Is it?
Yeah, just copy that.
Oh, just copy that. Okay.
Yeah, C++ allows you to do this hashtag define. It's interesting.
Hey, we're missing a
Oh,
semicolon.
yeah.
Sweet.
Yeah, that's a good error
Yeah,
to
easy to solve
have.
problem.
Oh, that's great. It works.
Okay.
Why is it so difficult to find the size of an array in C++?
I don't know.
Make sure it's working. We should get 0, 1, 2, 3 with 0, 1, 2, 3, 4. So
Good
5.
call.
Okay,
Sweet.
so it works. Okay.
Nice.
So to get every pair, maybe do something like
I think we need a for loop inside of a for
yeah,
loop.
inside of it.
Sounds good. And then probably -1 or maybe the first one's -1.
Oh, yeah, you're right. Because then +1 would go over. Oh. Okay, and then
For the second for loop, wouldn't it be my size of first element?
yeah, this is the first element.
For the second for loop, we're still iterating through the array.
It's not hard. It's free. Oops.
Nice.
Sweet.
I think that's a free combination.
Yeah, cool. Do we have to do 16, 16 as well? And where they're both the same?
Well, that would help us figure out if we're actually detecting pairs.
Sure. Also, if we do need the pairs of the same element, it would just be that. I don't know. Did he say that? I don't think he did.
Hmm?
Just leave it. What was the next thing to do?
I think we were gonna do the average.
Okay.
Yeah.
All right. So the average. So just add it up and then divide, right?
Yeah, he was also talking about like what to do if the array was large enough that it was larger than any data type.
So I was wondering if you add 1 to the maximum integer, does it wrap around, like become negative?
Usually it throws an error, I believe.
In C++, I don't know.
Yeah, I don't know.
When integer overflows.
So,
I
Hmm.
think it does overflow. I don't think it grows.
Yeah, I think it goes into the negatives.
no, that's too much.
Yeah, the only thing I can think of is somehow storing it as like a string, I guess. Because then you'd be storing like each digit, but I just don't know.
Okay. So what are we doing next?
I don't remember. Does anyone remember?
I think those were the ones he talked about.
Oh, this is it?
I don't know.
Oh,
I mean,
We
this
could
might be it.
we could try to do the what if you have like a million like random numbers or something.
Okay. So the array has, we're making an array that has random numbers.
Yeah, like a lot of them.
And a million is the size?
Sure.
So obviously we can't type it out like this. Does anyone know what we do here?
yeah.
So you can probably make a new empty array. I'm not sure what the syntax is.
Let me get it.
And then we can fill it in a for loop, maybe.
Okay. Let's see if that works first.
You can do this. Yeah, that should work.
There's a method to.
Okay, so there weren't any problems. That's good.
This is gonna be a little slow.
Yeah.
You don't have to keep using a different,
I don't.
no, since
Oh.
it's only confined to the for loop. You
Oh,
can
okay.
use int I for everything unless it's a for loop inside of a for loop.
Mhm. How do you do a random number? Again, I forgot.
You probably have to import something.
I remember it was called rand, but and then there was srand, but
You have to seed it too.
what do we include?
Stdlib.h. And time.h.
Like that?
Yeah, and then time.h.
Like
And
that?
then you only have to do srand at the top of main one time.
It looks like
Okay.
it. Just using a random seed.
So, and then like that?
So we want to base it on the time because the time is
Oh.
like, so it's like, yeah.
Okay, so that.
And then in parentheses, you pass in null. Maddie has the
It's
chat.
Oh, yeah, I see it.
Why do you pass in null? I missed that last time.
I do not know.
Okay. So now how do I get a random number? Okay.
Oh, right.
It's like this. I mean, use a different name for the variable, but
Oh, okay.
that would make a random.
We can use the same name. It's okay.
Can we use like, instead of modulo 10, like a really big number?
Yeah, you can put in any number there as your maximum, or
Or like 34,000. I want to see the overflow this time.
And then so how do I, or I don't think it'd be a good idea to print out every element.
oh, it's a
You want
great
to try
idea.
anyway?
Yeah.
Okay.
Oh, you might want to include a space. Oh my
All
god.
right.
Oh, that's awesome.
We're hacking into the matrix. Ooh.
Okay, so
Oh my god.
Space would have been a good idea. I'm gonna do that.
Maybe we should set it to slightly less, otherwise we're gonna be here a while every time we run it.
I think the C out is the slowest part, but I'm not sure.
Okay. Less or still 1 million?
I mean, we can keep it like that. It's just gonna.
Okay.
Yeah, we'll have to remove the C out before we get the average. Okay, what happens if we get the average of this one?
So the average is,
Overflow,
yeah,
probably.
and then we'll just change all the.
I'm gonna be.
Maybe I'll comment all this out.
you guys keep doing.
Or it doesn't really matter because we'll never see it.
Oh, you missed one. Sum plus
Oh,
equals.
yeah.
Yeah, I think it should be okay now, but maybe
Okay.
it'll still be too.
Redeclare. Oh, okay.
Okay, yeah.
Average is negative 190.
So it overflowed. Okay.
Yeah.
Okay, so how do we fix it?
Maybe you do you take the average of pairs. No, that's still.
No, actually, that's what I was thinking. Like, I was thinking if you took the average of a few of them and then you added a few more and then divided again. Do you know what I
Yeah.
mean?
Yeah.
I think
Okay.
that would work.
All right. So by pairs or by something bigger?
We can try pairs first. That sounds good.
Okay.
I think it'll still be 2, but
Okay.
pairs sounds good.
All right. So are we have a pair and
So
how would this work?
So we would add the 2 together and then divide by 2 and then add the next 2 and then divide by 3. Or what?
So let's say you have 1, 2, 3, 4. So if you're doing this by pairs, you first get the average of 1, 2. That's 1.5. And then average of 1.5 plus 3. You're not dividing by 2.
Oh, you're
dividing by
divided by 2. You're right. I think you're divided by 2 that time because you're still adding 2 numbers. You were right. Yeah.
So then 4.5 divided by 2 is 2.25. Then 2.25 plus 4 divided by 2 is what? Well, we should get
Like-
2.5 as
like
the final
3.
answer. What was that?
It's we are. What are we supposed to get for the final answer?
2.5. Yeah. So maybe if you or maybe it's divided by.
So the problem with this is that if you want to do this kind of thing, you have to get into really complicated weighted averages. So
So maybe we should do another problem. Maybe this is not for right now.
Okay.
yeah, I would say that this is pretty hard because if you just do it, you're doing like add a thing and then average again, then it messes stuff up.
Yeah.
Yes, it does.
So let's leave the average at negative 190 for now.
Or you could like, I don't know, maybe try using a long for your sum
Yeah, would that be big
Okay.
enough?
I don't know if it would be
Sorry, I'm
enough
back.
though. I don't know if that would be enough.
What did we get done?
Well, nothing. My idea didn't work. So
Really?
Check this out.
yeah, it might have worked if we like stored the number of things, but
I don't know. I did it for a much smaller array of like 1,000 entries, and the numbers are between 1 and 10,000, and it worked fine. But
Okay.
the
maybe a
so
log was work.
17,001.
Yeah,
That
I-
might be right.
it just
Uh,
it's just that like the array was only 1,000 long, and then
uh-huh.
the numbers could be between 1 and 10,000. So
Yeah.
I don't know.
I
That
kind of
wasn't
want the professor to help us through. Maybe we could do it.
maybe.
Wait, what does RAND give you again?
Rand, I don't even know. It just
Oh,
gives you
it's
some number.
between 0 and some kind of max integer.
Oh, okay, that
Okay.
makes sense. That
This
makes
is
sense.
between 1 and that max. And
Oh yeah, I think this, we got the
That's
right
why we have to
answer
do the
when we
modulo and stuff.
changed sum to long, because with modulo, everything has to be in between 1 and 34,000. And then the average is 17,000, which is half of 34,000.
Seems fine.
So I think, yeah, changing it
Nice.
to long got us the answer. Yeah, and that's kind of close to 17,000 as well.
good job, guys.
Yeah, good job.
So was there anything else we should do?
He didn't say anything. I kind of want to flag him down, but I'm not sure if he's listening. We could like, I don't know, do like an array of arrays, like a 2D array.
Okay.
That would be interesting.
And
Well,
like,
they definitely exist.
yeah.
Mm,
And
And then
the
what should
average?
we?
Or-
Sure,
and
we
what-
can get the average of the 2D array.
Oh no, wait. I don't know why you'd want to do that.
And what do you want to put in it?
I don't know. Will it work if you do like bracket and then bracket like again? Yeah.
yeah, theoretically.
Yeah, I believe that's right. Makes the most sense.
Oh no, it's just it can't be. Must have bounds for all dimensions.
Oh, so
Because
the,
yeah.
yeah,
So
So
just put 2 in it.
or I think it'd be 2 and 2.
Yeah, just put 2 and 2 in it.
okay. So no errors. And now we find the average. Or we
So do we just
The
want to find the,
average?
should we just find the average of the 4 numbers or like store the average in a 1D array?
And then find the average of that 1D array.
Oh
Sure,
my gosh.
I don't know.
Hiram.
I mean, I don't even know why you would want to store the data like this.
You wouldn't, but
Unless you were doing like 2 groups, like if you were taking the average of one group and then comparing it to and then averaging it with another group's average. I don't know why. Oh, wait, what would you do that for?
Hiram doesn't like fun. Confirmed.
Phone?
for
Fun.
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 Doesn't understand the word
Wait.
fun.
Yeah,
Wait,
Hiram's
but-
like,
but-
fun? What is
Phone?
that?
I just didn't understand foam, but phone?
Sure.
You were saying phone.
It's my bad then. It's my Californian accent.
Obviously, I just have no idea how to have any fun in my life, and I'm
Yeah.
stuck just coding and I don't know, dying slowly.
Yep.
Do
Okay.
this. Or we know it's
Wait,
two.
wait,
Let's
wait.
just do two.
I don't
What?
know if this is helpful, but you can do the for each arrays. They're very helpful.
Let's
Oh.
try that. That sounds fun.
So how do you do it?
Okay, so a for each array is nice because like you don't have to write so much and it goes through an array. I don't know if it'll work on 2D ones, but I think it should. Anyways, you do okay, so you're gonna want to do like yeah, I don't know how to do it for 2D arrays now that I think about it, but
2D arrays you
If
can
you do it for 2D, you
theoretically
just
do.
have each thing would be an array.
Yeah, it should be
Yeah,
okay,
so
right?
you could do like I don't know, maybe like int I with the brackets or something. Oh, wait, no, you still need the you still need the
Yeah.
the
The parentheses.
Oh, okay.
parentheses, yes.
I was like, what the fuck are they called?
Oh my gosh.
Okay, and then and we give it some name, right?
Yeah.
Yeah.
No, yeah, we need to give it a name. I would just give it like I, but the brackets go after the name, don't they?
Yeah.
Int I in,
No, you still need the int.
yeah, int I in 2.
It actually says in, or is it colon?
No, it's a colon, it's colon.
Okay.
And then, as a matter of preference, I would space the colon out so it's not right next to the I, but yeah. And then for int j in I, I hope this works.
This is cool.
We
can do
I
like
don't
see
think
out.
we have the X though for. No, never mind. You're right.
Uh-oh. Uh-oh. Uh-oh.
What?
It didn't work when I tried it.
What happened?
Uh-oh.
What did it
Let's
say?
see. The initializer fails to determine the size of I, and the array must be initialized with a brace closed initiator. Okay, so it doesn't
Ooh.
like this.
I wanted to see the error. Oh, that won't work, right? You'll have to do the less than instead of plus.
Yeah, that's for sure. I'm trying to figure out how I could fix this. Because like it might be a lot easier to just use normal for loops here.
I'm so sorry, guys. I am not feeling very well, so I'm gonna have to go.
Okay.
Okay.
Yeah, keep
We're
this
almost
up.
done anyway.
Yeah.
Yeah, that's
sorry.
true.
Bye, everyone.
Okay. So now, but if I do, but if I just switch it to 2D.
Oh yeah, I don't know if this
That'll
will
give you
work.
2 as a size, not 4. And
Yeah.
then that, so this would have to be multiplied by this whole thing.
Wait, what are you doing?
I'm
Yeah.
trying to find the size, assuming
Oh
we don't know
gosh.
it already.
It's
Wait, oh my gosh, that's complicated.
it's 2D
Yeah.
0. It's even
Ew.
0 and
Ew,
then
ew,
0,
ew.
0.
and then 0 again.
Oh my gosh, that's disgusting.
Yeah, and we need.
I want to. I like actually hope that there's like a way to like make a dot size operator on an array. Like,
We should
can I
make
just
a
make it myself?
refactor this next class.
Aw. Oh my
It's gonna
gosh.
be so fun.
Wait, you know what? I'm
It
not-
didn't
I'm
work.
not-
Oh.
I'm not doing it.
Um,
Int I.
What if you put a 2 in the int I bracket?
okay. Oh,
I is less than
Which,
size
I
of,
mean, that could be okay, like, you know the size.
2D. Size of 2D. Oh shit.
No.
it's enclosed. Initialize.
What does that mean?
As I said, it didn't work when I did it, so I'm changing it right now just to use the
Okay.
normal method. I don't know what's going wrong. I'm not skilled enough in the C++.
Okay,
So it just has to do. We have to do this.
so no for loops. I mean, for each loops.
Well, the inner for each loop is fine. It's just
Oh,
the
okay.
outer one. And we'll have to rewrite the inner one a bit, but it shouldn't be a big deal.
Oh yeah, but the inner one doesn't work without the outer.
Not exactly, but we can reword it so that it works fine. Because it's just a int j in instead of I 2D I.
Oh, okay. Yeah. Change it to that.
Also, I don't know where you got this whole like my size of thing, but just size of works fine and you don't need to import anything for it.
Oh,
yeah, I
okay.
copied it from
We
somewhere.
copied it from like Stack Overflow.
Oh, well, I don't know where you're doing because I also went to like Stack Overflow, but I didn't.
Really?
I didn't
Well, it
it
wasn't
just
Stack
sounds like-
Overflow. I think it was Geeks for Geeks.
Well, whatever.
Yeah, but I think
I-
this is
Doesn't
right.
really matter.
But do we need, so size of, does it give you the number of bytes? I forgot.
I got something weird. Wait, did I? Ha, I know, I just forgot. That was stupid.
Size of yeah,
I think did we get the correct answer?
1005. That should be right. It looks right.
It does look
Wait.
correct.
Yeah, I wouldn't be surprised if it worked.
Yeah. Okay.
All right, cool.
So I don't really know what we're supposed to be doing. I've just been sort of following along. Like, what are we supposed to be doing
Well,
with this? Are we like practicing arrays and looping?
Yeah.
Yeah.
So first we were
Okay.
supposed to print out all pairs of an array.
All pairs? So like all the different combinations?
Yeah.
Wait, you never solved that one then?
Oh, it
think
was
we
up
did.
here. Like, I don't know. if you
Oh,
can see
yeah, there it is.
Yeah.
Yeah, I can see it now.
it. And
Okay.
we did finding the averages
Finding
of
the
all the elements in
averages.
an array, and finding the averages when there were
let
a
me
lot
see.
of, when there were 1 million elements. And then this was just something Alexandria thought of, the 2D array.
Yeah,
Okay.
I ran out of things.
Yeah,
Yeah.
I've been doing a lot of 2D arrays for a while now. I find them really annoying. I was doing them in a completely different language, so it doesn't help.
All right, well, I think this is everything.
Yeah. Wait, can I look at the pairs? Because I saw
The
something
code
big.
or the
Yeah,
actual
the code, the
pair?
code, the code, the code. Wow, that looks so complicated.
Yeah.
Wait,
so you find
mine's 5 lines.
I think it's just
Wait.
because we're assigning first element and second element.
Oh yeah, yeah. So why did you do that?
you
Just,
go,
I don't know.
you take
Just
the
because?
16 and
It's
pair
not
it
like
with
you-
each one, and then the 2 pair it with each one, 27,
I see.
77, and everything after. And you don't have to go before because you
Wait, everything after?
It.
Everything after?
Yeah,
Wait, that doesn't work, does it? Yeah, that doesn't work. Because
Are
if
we
it's everything
missing or
after,
over?
then you're missing the ones before.
but if
Oh, we
you
did.
count 16
No.
and 2, and then counting 16 and 2 is the same as counting 2 and 16.
It seems fine. Yeah, we
Oh,
got the
wait.
right answer.
Wait, what is...
The order doesn't
Sorry,
matter.
I just don't get it. Wait, x plus 1
I can post it on
I
Reddit.
think
Wait,
it
so
was
does it,
okay.
wait, so when you go past the index, does it loop around or something?
Oh, we never
Did
had
we
it
go
go past
past
the
the
index.
index?
The
I think we,
first loop never goes to has this -1, so that the second loop doesn't go over out of bounds.
Wow, this is really confusing to me. Mine was very different. I just looped
really?
through the array twice, right? Using I and j, and then if I is equal to j, then I continued, and then I just printed out the
oh,
combination of them.
I'm not sure which is better because usually using continue is discouraged.
Really? Okay.
Yeah, same
I
with
don't know.
break.
I'm just using it to like skip the rest of the code. Like I could
Yeah.
use an if statement to well, actually no. I'm using it to prevent nesting, but like I could just use if I is not equal to j, and then I could continue with the rest of my code and it would work the exact same. So I
Yeah.
could rewrite it, but like
Well, we have time. We can do it that way too. Or you can share.
I mean it's super quick. So in fact,
Wanna
I actually
share
did
or
it
you
the
want-
slow. I could share. I could, but like whatever.
Okay.
Wait,
then,
because I have to
keep
rewrite it.
going.
Wait, so what it would be is like for, oh wait, I could use a for each. Yeah, I can use a for each. Int I in array. So mine's called array, yours would be called foo.
Ooh, yeah, let's use it for each.
And then for int j in int j in array. So there we are. And then you can just do if I, so you don't like me using
Well,
continue, right?
So
Not equal to j.
will this work? Because if you have duplicates in the array, then you won't notice their pairs.
No. Oh, wait. So you have to like make sure that they're not duplicate
Yeah.
numbers on
Well,
top
like
of that?
if you have 16 and 16 next to each
Okay.
other, then it's
Well,
fine.
in
with the
that
pair.
case, no, in that case, it's like really easy because like all I have to do is add something into my condition. So in this case, what I was doing is I was not going into the array to make things easier. But what I can do instead is say if, oh, why did I type int instead of if? If array I is not equal to array j, and then I can see out.
Oh
You
yeah.
need to change this. Oh, I don't want to do that.
I don't know.
No more for each
Uh,
loop.
foo
or-
I is not equal to foo j. It's foo j.
Yeah. I'm
Sorry,
just- no.
I didn't. Sorry.
So,
Wait, so why'd you change the first one?
Yeah, we're still using a
because-
for each loop.
but I would be the something like 16. But if you want foo I, that would be the 16th element, which doesn't
I think
exist.
they're the same. Who I should be the same as.
Wait, if we're using a for each loop, we don't need the. I'm so stupid.
No, you're not stupid.
No,
I'm
okay.
confused.
Just a sec. Okay, so you see, the problem is that I just did something completely unnecessary. You know how I said like we need to like make sure that it's not that? Well, all that we need to do to make sure that the numbers aren't equal so that we don't print out a pair of like 16, 16 is
Oh, no.
just say I is not equal to j because we're in a for each loop. In my original method, it was the indexes and I would actually have to be worried. But no,
Okay.
Oh, okay.
All right.
not equal to j. Yep, and then I don't need the array I here either.
So if they're not equal to j, if they're not equal, you
And we print them. Okay, this sounds good. That was easy.
Now the question
Well-
is, does it work?
Yeah, will it print 6? It won't. It won't. Yeah, look at it. Look at that. That's pretty
should
cool.
have,
I like this better.
okay, 16.2, 1677, 1640, 216, 277.
Oh, but what if it's like a reversed one?
Yeah.
That's interesting.
So yeah, so 16.2 and 2.16 were.
Because yeah, I don't know. It depends. Wait, is it called permutations or combinations if you include the reversed ones?
I don't
If order
remember.
matters. Wait, let me search it up.
Permutation is order matters, I believe.
Yes. Okay, so then I guess I'm doing permutations instead of combinations. Well, whatever.
So if we wanted order to matter, then we have to loop backwards. Also.
No, I think your method is the right way to do it if order matters. It's just that your lines are so long because you use the my size of.
Yeah.
Yes.
And then and you like start it in the first and second element, which is a bit strange in my opinion.
It is
like
strange.
it's harder to type first element and second element and when you're just using foo x and foo y. So it's a lot of extra like space in the computer and like typing.
Yep.
Yeah, I guess. I guess that makes me a programmer, not a computer scientist.
Oh yeah.
Anyway, I think that's about it for today.
Yeah, pretty much.
Okay,
So
then
I
I'll
wanna.
post this on
Wait, I need to
Reddit.
change mine now.
See you guys.
All
I
right.
have a quick question.
Yeah.
I was waiting until it's like a good stopping point because like it I don't think it helps further what you're doing. But when you're doing like the including
Yeah.
for random numbers, I also saw like CSTDlib. Like what's do you know the difference between that and STDlib?
I'm guessing
like,
that the
does it matter?
CSTD lib is probably the C standard library instead of the C++ standard library.
Oh, C
Yeah.
C++
STD lib?
Well,
is
it's under like C++. Like it's listed under C++ stuff.
that's weird. I would, as I said, I would assume that it's in the C because they like to use a lot of backwards compatible stuff. So that's what I would think, but maybe. I don't know.
I was like reading about that stuff when you guys were figuring out like starting it, and it's like CSTD lib and like integer ran, so it's like slightly different codes than what we were using. I just didn't know the difference or whether it mattered.
I don't know.
I don't know either.
Okay, that's
No, I
fair.
think the other Maddie told me to include this.
Yeah.
So you have to ask her.
I'm pretty sure she looked it up too. I'm pretty sure. I think I saw it when I was like looking it up too, but like there's other things that also say the other one. So it's like people
Yeah.
are using both.
Oh, never mind. I got it backwards. Okay, so C standard lib, so CSTD lib is the C++ header, and the second is a C header.
Oh, okay.
Do you think that's because STD lib came first?
No, I think it's because stdlib.h has a .h, and C++ has this thing where it doesn't need its headers to be .h, but C always did.
Oh, okay. Oh, I thought we learned .h today, but I guess not.
Yeah, so the comment you put under it, it doesn't need the .h.
Oh.
No, it does need the .h.
It does?
Well, because you're importing that library, it is one that has a .h, right? Oh wait, CSTDlib. CSTDlib does not need the .h. Sorry, I wasn't looking. I was on my webpage.
Yeah, it's specifically the one in the comment.
Yeah. Sorry.
Okay. All right, then I'll go post this on Reddit.
Okay.
Yay.
I think I want to see the refactor.
Yeah, I sort of do too.
Yeah. Okay.
Wait,
Bye, guys.
let me see what I've got. I don't know. I don't know if I can refactor mine. I don't know. Okay.
I liked your for each loops though. That was good.
Yay.